Hello all. Hasn't been as long as the last time, but it has been a short while, so it's good to see you again. Now we're going to jump straight into it. Like I said, I haven't seen you for a long time, but I did say, oh no, I'm about to say that this is going to be quite a difficult topic, and we are going into some difficult stuff right now. GOTO systems is not the most difficult thing you're going to learn, but it's probably quite an advanced topic considering you haven't been on computing for a long time. I hope you'll be fine with it. If you understand this, then, well, even the next topic, that's harder than this, so we're just going to have to get through it. But I find this quite interesting, so I think you're going to have a bit of fun learning about this, but let's jump straight into it. The first part of understanding GOTO logic is to understand why it's necessary to have a program counter. If you don't know what a program counter is, it basically counts programs. So yeah, it's quite simple really, simple concept. A program counter counts programs, just like a clock, no, hold on, just like a runner runs or something. A really simple example, a program counter counts programs. It tells the computer what line of code it's going to execute next. It keeps track of the programs, it counts them, and it tells you where you're going next after the program that you've executed. So the reason that you kind of want different lines of code, it's because a program might want to complete actions one after another. For example, if you're hammering a nail into some wood that you bought from the store, you might not want to do everything straight away, right? Your first step might be to put the plank of wood in a bench. You put it down. Your second step might be put the sharp end of the nail against the wood. So put the nail into there, and then you might want to hammer, and you might want to hammer the nail in. But you're not going to try and, while you're holding the wood, grab a hammer with your pinky and then hit your pinky through the wood along with the nail. No, that's not really going to be very efficient. You're going to want to put it down, then once it's down, you're going to want to put a nail on it. Once you've put the nail on it, you're going to want to hammer the nail into the wood. So yeah, you wouldn't really want to do all these things at the same time, and the same goes for a computer really. If it's adding numbers and you throw a bunch more numbers at the same time that it's adding, then it's going to get really confused and it's probably going to start crying or something, right? It's not going to be very happy with this. So you're going to want to give it two numbers, wait till it's finished, and then give it the other numbers it needs to deal with. If you give them all at the same time, it's going to think, okay, which ones am I dealing with first? And it's going to get really confused. Unless it's a really advanced computer. But generally, no, you don't want to throw loads of numbers at one circuit at the same time, because it's just going to mess things up. So to avoid this, the computer waits until it's finished manipulating the data that it has, then it's going to deal with the new problem in the next line of code. This is usually the case, but there's an exception called an interrupt, where in the middle of executing a line of code, if something more important comes through, it's going to stop what it's doing, do the more important thing, and start what it was doing again. So yeah, that's why you want separate lines of code, because it's going to get confused. Like if you're hammering a nail into wood, you're not going to hold the wood, hold the nail and the hammer, and then start messing it all up and mashing it into a big ball. Same with a computer. It's going to want to do things at separate times. Okay, so we know why we want separate lines of code. We know that our computer has separate lines of code, but we do need to determine the order which these lines of code are executed. That might seem like a confusing question, but if you're after the simple sorry, I can't speak today. If you're after a simple answer, then the answer for you is binary. Now I've already told you actually why, like I've already told you how you keep track of these lines of code. I told you that you need a program counter. I also told you that you need a GOTO system. Now, the GOTO system is exactly the same as the program counter. A GOTO system is a specific type of program counter. It keeps track of the lines of code. And the way it does this is in binary. The lines of code are counted in binary, just like everything else on a computer. But I doubt anyone here is really going to be satisfied with the one-word answer, so I'm going to elaborate on this idea. The way that the program counter works is with a GOTO system, and on every single line of code is a set of instructions, so it tells the computer what to do. That's a line of code. A line of code is a set of instructions that says, okay, we're going to add this number and this number. Otherwise the computer doesn't know what to do. So the line of code tells the computer what to do, so it has some instructions, and it also has another number. This number is written in binary, the second number, and it represents the line of code that will be executed next. So after it's done whatever it's done, say it says, okay, we want to get these two numbers and we want to move them somewhere else. Once we've moved them, we might want to do something with them while they're in that place. So on the next line of code, we're going to say, okay, add the numbers, or subtract one from the other, or something like that. Yeah, so that's how that works. But the way that we go from one line of code to the other is with the GOTO system. We say, okay, we're on this line of code. Now we want to go to the next line of code, so we want to make the number go up by 1. So if it's on line 0, then we want to make it go up by line 1, and we'll go to line 1. Then we'll go to line 2, line 3, line 4, and we'll execute them in order. And we'll get a pretty successful program. So the line has two sets of instructions, really. What the computer's doing, so the add, subtract, the read, and the send to different places, that kind of thing. And what it's going to be doing next, which is the GOTO system, and what line of code it'll be executing next. Now, of course, if this is a bit complicated, if you don't really get it, don't worry, because I'm not leaving you with that. I don't plan on doing that. I'm going to boot up our old simulation of computing, and I'm going to give you a bit more of a visual demonstration of how this works. Okay, we're in Minecraft once again, and I'm going to talk to you about this GOTO system and how we get from one line of code, for example this one, to another line of code, this one here. The way we do that, like I said, is with the GOTO system. And here I've got a very basic GOTO system. The reason I've set it up like this is because we've only got 4 lines of code. It realistically should be a bit different, but you don't need to worry about that. And in our GOTO system, we have 4 commands, all these here. In fact, I'm going to highlight these with this block here. I probably should have done this off camera, thought of this, but it's almost done. There you go. Not too much of a fuss. Now here are our programs. We can either go to line 0, go to line 1, go to line 2, or go to line 3. Now a program always, no matter what, it always starts on line 0. You can make the program start doing things on line 1, but you need to start on line 0, then go to line 1, and then start doing the things on line 1. But the program will initially start on line 0. So when you execute the program, it will start on line 0. Like I said, it's going to start on line 0. So when you execute the program, it starts here. And we can make it do stuff here, like we've got some instructions already. We've got these instructions here with the computers doing something on line 0. But after it's done that, we're not going to keep wanting to do the same thing over and over. We're interested in what's in line 1. We've done line 0. We want to go to line 1. But how do we do that? Like I said, we need a program counter, and here's our program counter. We have a GOTO system. Now, if we want to go to line 1, do we want go to line 0, go to line 1, go to line 2, or go to line 3? The answer is quite clear for me, perhaps not for everybody, but it's go to line 1. If you want to go to line 1, then we need to use the program go to line 1. So, the thing about a GOTO system, okay, when it will only go to the next program after this line of code is finished. It's a little bit complicated. It involves something called registers, but basically, what you're not going to want to do is you're not going to want to how do I put this? You're not going to want to start doing this, and in the middle of executing, it's going to immediately go to line 1 and forget about what it's doing, because that's not going to be really very useful, is it? Instead, it's going to do what it's doing, finish what it's doing, and when it has finished, it's going to execute the GOTO commands, and it's going to go to line 1, and then it will do itself in here. And then wherever you want to go from line 1, you'll go to there. So you want to go to, okay, let's put some commands on this actually. We'll go to line 1 after we finished. Okay, after we finished on line 0, we go to line 1. We're not going to do it any time before we finished. And then once we're on line 1, we've done all this stuff. We're about to do our execute some commands on line 1. After this, we're going to go to line 2. We want to execute whatever's on here. There's actually nothing on here, but imagine computers doing stuff. There you go, a few torches, blah blah blah. Now the computer's doing stuff on line 2, sorry. And we're interested in that, but only after we finished here. So after we finished on line 1, we're going to go to line 2 by executing the command go to line 2. There you go. Now that that's in place, after we finish with line 1, we'll go to line 2. Now on line 2, let's say this is the last thing we want to do in the computer. Now there are two things we could do here. We can either go to line 3, which we could put here. Now we'll go to line 3, and we'll end up here. We'll end up on line 3 as the last thing. Or we could just stay on line 2. The way we do that is we put a torch on the line 2 column. So if we execute the command go to line 2 while we're on the line 2, then it's not going to go anywhere because it's going to 2 from 2. So it's going to finish on this line of code, on line of code 2, with whatever it's doing on line of code 2. So that's our go-to system. Now, the way that this works, Alright, so like I said, you need registers. In fact, I've got a better example. Let's go over to that. We're just, sorry, I've got a bit of a snotty nose right now. Not particularly pleasant, but I'm having to deal with it. Alright, we're at our better example. Don't worry about any of this. It might look like a mess to you. We'll get onto this later, in a couple of minutes. No, I'm joking. This takes ages. I swear, months of practice to build this. But here are our registers, like I talked to you about. Now, what register does is the register basically makes sure that we don't go to the next line. So here are our lines. So let's imagine that this is go to line 1. This is go to line 2. In fact, now let's do it from left to right. This is go to line 1. This is go to line 2. 3, 4, and 5. So we have 5 different lines of code. Let's just imagine that for simplicity. So 5 lines of code, just like I said, and we want to start on line 1. Like I said. So, oh no, sorry. I completely messed this up. This is line 0. This is line 1, 2, 3, 4. So there's 5 lines of code, but it starts on 0 and goes to 4. So we're going to start on line 0, but before we go to line 1, we want to do what we're doing. So we want to do the rest of the instructions which are down there. Once we finish that, we'll go to the next line of code. And this is what a register does. It doesn't let us go to the next line of code until we've finished what we're doing on the current line of code. And we have a clock to determine that. So the clock speed might be, I don't know, 1 second, as I've got here. So after 1 second, it'll go to the next line of code. And you might say, oh no, what's going on with this? There's no control over it whatsoever. Well, there kind of is. Because perhaps 1 second is all that the line of code needs to execute. After 1 second, it will be done. So we don't need to wait for it. We can wait for the clock to finish, we can wait for the clock to complete a cycle, update the registers, then go to the next line of code. So after the clock's finished, we'll go to the next line of code. And we can time the clock with the same. We can time it so that it's in time with our program. So say our program takes 1 second to execute, we might have a 1 second fast clock. This way it waits for the program to finish before it goes to the next line of code. So there's GOTO systems for you. We're going to head back onto the PowerPoint and wrap things up really quickly. And yeah, you should have a basic understanding of things like clocks, GOTO systems, and all that now. So see you back on the PowerPoint. So that should be it in terms of GOTO systems and program counters and stuff. We're going to go next time into a bit more into depth a bit more. Oh my god, I've completely messed up that saying. In fact, I can't even remember how to use that saying. We're going to go a bit more in depth, that's it. And we're going to talk about conditional branching. So, based on the condition that you are enjoying these videos, I might see you next time. But based on that condition, alright? Alright, so it is conditional. That's giving you an option. That's the clue about what conditional branching is based on. Oh my god, I can't get it out of my head that I feel like I should go over registers and things like that. And how they work. I really should, and I really should tell you how information gets around the computer. In fact, hold on. Wait, I'm coming up with an idea right now. Anyway, we are done with this video. We are done with GOTO system. No, we're not done with GOTO systems because conditional branching uses GOTO systems. We're done with explaining the basic logic behind GOTO systems. We're done with clocks. Yes, we are. Thank goodness for that. That was the awful explanation I gave earlier. We're done with clocks, GOTO systems, and hopefully you should be able to program at a basic level in terms of do this, then do this, then do this. Next time we're going to do conditional branching. Like I said, if you like these videos, I'll see you next time. But yeah. So programming, I really should leave this for the next episode. I just want to say though, I just want to say one more thing. You know how to program at a basic level. I want to tell you what we're going to be doing in the next video because it's so important. I think you should have a think about this, and yeah, go away after this video, have a think about what I'm going to say, and come back to the next video and compare what you thought about with what I'm telling you. Go to the next line of code. If this is true, if it's not true, do something different. Go to another line of code. See you next time.